Hello everybody, Sean here with a video. This time it relates the maximum principal stress criterion and the Coulomb-Mohr criterion. The state of stress at a point in the structure sigma ut, like the tension, is equal to 350 megapascals, and sigma UC equals 825 megapascals. That's the compression. And those are essentially like boundaries. They're described by sigma XX equals 75 megapascals, sigma YY equals negative 210 megapascals, and tau XY equals 250 megapascals. Determine whether failure occurs at the point according to A, the maximum principal stress criterion, and B, the Coulomb-Mohr criterion. Okay, so to start us off, first we're gonna draw all the stresses, pretty much we're gonna write them out in the matrix. So sigma XX equals 75, and then 250 for XY, and then for YY it's negative 210, and then the rest are all zeros. Okay, so from there we can go, let's note down that our tension has to be below 350 megapascals, and our compression has to be below 825 megapascals. So sigma 1, 2 equals sigma XX plus sigma YY over 2 plus square root of sigma XX minus sigma YY over 2 squared plus sigma XY squared. So over here, sigma 1 and 2 are the principal stresses, and this is a general equation that you can use to find them. Alright, so sigma 1, 2, then I equals 75 minus 210 over 2 plus or minus the square root of 75 minus 210 over 2 squared plus 250 squared. So sigma 1 comma 2 ends up equaling negative 67.5 plus or minus 258.95, which ends up equaling 191.45 megapascals and negative 326.45 megapascals. So 191.45 megapascals is equal to theta or sigma 1, and negative 326.45 megapascals is equal to sigma 2. So from this, we can tell that sigma 1, which equals 191.45 megapascals, is less than 350 megapascals, which is equal to sigma ut, like the limit, the tension limit. And then, so that's good. And then for sigma 2, we can tell that negative 326.45, which is really 326.45 in compression, since it's opposite, it's negative. From that we can tell that is less than 825 megapascals, and so which is equal to the compression, max compression essentially. And so that checks out. And since these conditions both check out, Therefore, failure does not occur according to the maximum principal stress criterion. Okay, now moving on, let's deal with the Coulomb-Mohr criterion. So the thing with the Coulomb-Mohr criterion is that we have to take the principal stress 1 and divide it by the tension, like the maximum principal stress, or the maximum stress, the maximum tension stress, and then take sigma 2 and divide it by the maximum compression stress, and then if this is equal to, or if this is less than, I should say, 1, then this checks out. So from our case, the ratios we get are 191.45 over 350 minus negative 326.45 over 825, which is less than 1. So 0.547 plus 0.396 is less than 1. So finally, we end up getting 0.943 is less than 1. And since this checks out to be true, therefore, failure does not occur according to the Coulomb-Mohr criterion. Alright, thank you everybody for paying attention. Best of luck.